So yeah, thank you guys for joining today. I'll be talking about building Omnichain applications. First, a little bit about me. GM, my name's Matt. I'm a developer ecosystem lead at LayerZero. You can follow me at Uncrackable on Twitter or X. And I figured if we're going to talk about bridging, the best place to start would be with real-world bridges, because even though we call them bridges in blockchain, the analogy is fairly similar, right? Bridges at a high level, all they do is they connect isolated groups of people. And what's really interesting about that is by connecting isolated groups of people, you get access to information. And information can be used to do things such as coordinate the movement of goods and services. You can also use it as a way to, take track of account, of unit of exchange, of different financial utilities. So being able to use a bridge is very, very valuable from the information standpoint. And jumping into crypto, I think that makes a lot of sense for the industry as well. If you look, this is the Electric Capital developer report from last year that saw that in the last year, 34% of all developers working on open source crypto projects deployed on more than one chain. But if it's that obvious, right, the utility you get out of cross-chain, why is that number still so low when compared to people only deploying on a single development environment? And to answer that, I think it's probably worth explaining how do cross-chain transfers even work from a high level. So right here, you can see one blockchain with an ERC20 token, right? At a high level, moving tokens between chains or moving tokens between users is really all you're doing is calling a contract interface and saying, hey, I want to debit this balance from my account and credit this balance to another user on the same chain. And the chain takes the place as a ledger. You're using that ledger just to update state and say, I'm moving balance from person A to person B. But as soon as you move to more than one chain, that immediately becomes problematic, right? With more than one chain, you have to think about 1A. These chains have no way of communicating with each other. They don't know each other exist. In a lot of ways, they're just segmented islands, right? No one can communicate between them. So ideally, if we were going to try and send a message cross-chain, the way that we would go about doing it is first, A, find some way to still debit a user for, say, moving tokens, right? Take it out of their account and ensure that it's gone, and then be able to emit that event from the source blockchain and somehow deliver it to the destination chain where a second transaction can be written, and that logic can then be received to the destination user's account. The way that this traditionally worked historically was with monolithic bridges, right? You can think of this as any centralized provider, as a collection of different signers in a network, as a middle chain itself. It doesn't matter. Broadly speaking, this is a security mechanism to make sure that, hey, what happened on chain A actually did happen, and now we're going to forward the actual message to the destination chain. But one of the big problems that you might run into here is what happens when this security fails? And this isn't a theoretical question. This happens time and time again, especially over the last 2 years. Multiple bridges claim to have some unique security property about them, only to have their security fail, and not just you as the application owner get hurt by this bridge failing, but every application owner that deployed on top of this security mechanism is now at risk. And so from a high level, if we look at the biggest exploits in the crypto industry in the past 10 years, you can see that 4 out of the 5 largest hacks are due to this type of monolithic bridge security, trusting some validation mechanism to be able to deliver messages on your behalf that goes rogue. And furthermore, this doesn't really make a lot of sense anyways when we talk about cross-chain as a concept. We know that already we want cross-chain to solve a valuable pain point, which is that developers need to make trade-offs between speed, cost, and security when picking which blockchain they use. Why should my bridging ecosystem as well force me to lock into one monolithic standard for how to move messages between chains? It doesn't fit the same problem area it's trying to solve. So ideally, if we know that each of these chains are their own separate island that don't have a common way of communicating with each other, how do we go about building a good global ledger for communicating data between each of these blockchains? Ideally, if we were going to have this type of point-to-point communication, the way that you would go about doing it is 1, make it permissionless so that any application, any smart contract, any user can still access the protocol to send a message from chain A and deliver it to chain B. You would want to also make sure that once that message has been called, has been sent, you're able to then ensure that the protocol itself doesn't swat down messages that it doesn't like. It has to be censorship resistant. And 3, it has to be immutable. The contract code deployed on each of these blockchains can't be upgradable. It can't fall prey to if someone pushes a faulty update or things that might be malicious intent on the blockchain itself. Oh, new microphone? We'll trade it out. No, you're good. Is that better for everybody? Awesome. Great. So yeah, high level, 3 principles, right? Permissionlessness, censorship resistance, immutability. It's essential for you to be able to do that in a cross-chain environment. At a high level, the way that LayerZero sees this playing out is that we believe in omni-chain applications, where any smart contract on any blockchain network can communicate with a LayerZero endpoint smart contract also deployed on that network and be able to move messages seamlessly between any point on this network. What that means at a deeper level is that, say, for that token transfer example we brought up, right? A user can communicate with a smart contract that is using a LayerZero contract standard. They can debit the amount of tokens that they want to send to a new chain and communicate with that LayerZero endpoint, the smart contract interface. And what that interface gives you is the ability to then choose which verifier networks I want to have validate that that message is legitimate. When I say verifier networks, think of security mechanisms, right? This could be a collection of 2 of 3 any verifier networks that are enabled via LayerZero. And what these verifier networks give you is the ability to have independence between security. These each have their own mechanism, which I'll dive into in a little bit here, that validates the message property and makes sure that, hey, this is a legitimate message independently of each other. And what that means is that now that these verifiers exist, they can deliver that message to the destination chain via the LayerZero endpoint contract, and then credit that balance to a destination user, all with the developer knowing for sure that, hey, even in the worst case scenario, if one of these verifier networks fails, the worst case scenario is that messaging is just paused until I take it out and plug a new one in. The best case scenario is that the end user doesn't feel it at all. And what that means is that for a user and for a developer, you now have access to multiple different types of validation within the same bridging framework. What that means is, again, you don't have to learn an entirely new ecosystem every time you switch bridges. You don't have to redeploy contracts every time you need to update validation. You can just use normal smart contract access controls that are already available and already audited as a way for you to configure each validation property, whether that's a ZK-Lite client, whether that's a combination of that ZK-Lite client with a Web2 entity, whether that's an existing messaging service provider like CCIP or Axelar. You can combine any combination of the 25 available DVNs or decentralized verifier networks that LayerZero currently offers and use your own unique security configuration really as the way for you to move messages between point A and point B. And that means you're future-proof. You no longer have to wait and hope that this one bet on one validation technique will succeed. Instead, you have safe configurability. At a high level, the messaging workflow works like this. An application sends a message. That message could be a token transfer, it could be an NFT transfer, it could be a governance vote, it could be a token-bound account, it could be anything that you do on a smart contract. It gets encoded into data. Once it's encoded as a bytes array, that message is emitted to the application's chosen security stack or DVNs and the executor. Then those security stacks sign off, making sure that they deliver the payload to the destination chain. And finally, once that hash of the payload has been delivered, an executor can come along and execute that message, either permissionlessly, where a user manually calls the destination chain, or automatically and gas abstracted on their behalf. And so going back to this view, right, omni-chain applications, again, this means that any smart contract can send any message between each point. They can configure it in a way where they not only own the whole mesh, but also can configure any point on the mesh as well. And this configuration gives you the ability to not only own the block confirmations that you have to wait before emitting a message, you can configure the actual security and the quantity of verifier networks that are within that security stack. You can also control the execution logic like I mentioned before. So in the top view, that's automatic execution. A user clicks once for a transaction on the source chain. That message is delivered to the destination chain. Their gas token is swapped for the destination gas and executed on their behalf, all without them having to do anything, or can still be done manually. And the great thing about this is it means it's permissionless. If executors ever disappear one day, right? If the LayerZero executor ever gets shut down, censored, reduced, told by a government to get out of here, right? you as a developer can, one, run your own executor and immediately pick up where you left off and start running messages, or anyone really can actually just call the LayerZero endpoint directly with their wallet and deliver that message for them. So you have a ton of flexibility when it comes to being able to execute messages. Even deeper than that, you can actually control per message the type of gas settings that I want to have when I'm delivering it. So think of it from this angle. Once this message has been received on the destination chain, I can say that, let's say for the token transfer example, right? I wanted to send a token and have it mint, and I'm minting it using this amount of gas and this amount of message value on the destination chain. And after I mint that token, I want to have that token then swapped for a new ERC20 that's only on the destination chain. That composed level functionality enables you to price the amount of gas it would cost to swap it, to stake it, to do anything subsequently after the receive logic has been executed. So it gives you a ton of permissionless flexibility in how the messages are delivered. Or if I just want to airdrop a user's wallet on a destination chain and say, hey, this user's going to a brand new chain they've never been to before, let me fund their wallet so that they have a seamless experience from day one as soon as they get on board. There's a ton of limitless opportunity here when it comes to building on LayerZero. I won't go over this too much, it's more developer focused, but you can also control the order of message delivery. So it's unordered by default. If you want to have it ordered to, let's say, ensure that every single message has to be delivered in the exact order it was placed in, you can enable that too from the application settings. You can control the max message size to ensure that you have valid data types and there's no weird wonkiness in how that message is being delivered per your smart contracts. And broadly, this means that LayerZero is composable, right? Not only can you use the protocol itself to move messages between any blockchain, but you can have it then call multiple different contracts, multiple different applications subsequent after that receive is delivered. And you can even call LayerZero back again itself in the receive logic. So I could say move from Ethereum to Polygon, back to BNB, back to Ethereum. And we have a bunch of projects already that are doing this, like Tapioca DAO. And so broadly, what this means for users, for developers, for everyone, is that there's an omni-chain tech stack. You're able to build any type of application you want on top of LayerZero, either using provided contract standards that we offer out of the box that make this a lot faster to develop, either the OFT or the OAP, or broadly, any smart contract that's deployed on a source blockchain can communicate with a LayerZero endpoint on that same chain, configure any of the properties they want, and deliver messages. Today, we're live on 50 plus different mainnet chains. We've been around for about a year and a half now, securing billions of dollars of TVL. So feel free to scan this QR code on the top right if you want. That'll give you a link to our docs, to this presentation, to my personal Telegram, to my LinkedIn, to our Discord. Grab it, save it, get anything you need from it, and it'll give you just a really handy way to get in touch with us. So thanks so much. Happy to take any questions from here.